Okay, I quickly want to make this video. So see, when you hear relative velocity in one dimension, first of all, you know that relative velocity is simply the motion of a body, or you say the velocity of a body, let's say A, as observed by B. So the relative velocity of A is simply the motion of A that is observed by B, while the relative velocity of B is simply the motion of the relative velocity of B due to A is simply the motion of B as observed by A. So when you hear relative velocity, it simply talks about motion of a body as observed by another body, or you say motion of a body due to another body, and that due to simply means as observed. So if I know that there are two key things or three key things I just want to state, because I want this video to be very short. So let's say this is a car and this is another car. Provided they are moving in the same direction, everything about relative velocity is simply, so relative velocity for these two now will simply be equals to relative VA, the velocity of A, or you say velocity of A. So relative velocity of A will simply be VA minus VB, and relative velocity of B will simply be VB minus VA. So remember, this is like definition. So if I've noted this, so if, for example, what this means is that if I have a velocity of an object A to be equals to 20 and that of B to be equals to 10, and they ask you what is relative velocity of A, so relative velocity of A will simply be 20 minus 10, that is velocity of A minus VB, which is equals to 10. But if they ask you what is the relative velocity of B, it will simply be relative velocity of B minus relative velocity of A, which is 10 minus 20, which is equals to minus 10. And notice that the reason why is this way is because they are in the same direction. I'm taking it that they are in the same direction. I'm taking it that, let's say this is the 20 and this is 10. This is A and B. They are in the same direction. Now, let's say as this thing is here, as this object, that is this car, the two cars, as they are moving, let's say that there is someone inside this car, or let's say this is a train. Okay, let me make it another example. Let's say this is a train or a G5, and this is another G5, and let's say somebody is inside this car running, and let's say there is a ball rolling inside this car, and they ask you what is the relative velocity of should I say this part. Let's say I call this thing A and I call this B. Let's say this car is moving with velocity of 10 mph and this one is moving with 15 mph, and they're moving in the same direction, and let's say the person running is moving with velocity of 2 mph, and the two balls, they are moving with, let's say this one is moving with 3 mph, or let's 2 mph, and I want to calculate the relative velocity of the two cars as observed by somebody standing on earth, like standing on the ground. What the person will simply see, if the person notices that this person is running, and if this person can see that the ball is rolling, what the person will clearly see is simply 15 plus 2 for this one, which will give you 17. So what this thing is simply saying is that the relative velocity, when checking relative velocity, for a particular object, you are going to be considering all the velocities there added up. So let's say I come here now for this one now, relative velocity, or you say everything happening here, relative velocity on this one, this particular case, be it the ball or this, is going to simply, provided they are moving in the same direction and they are in the same place, or you say provided a motion is happening inside, the motion of a body is happening inside another body, the velocities there will be added up. That's what I mean. So this one is simply going to be 10 plus 2 plus 3, which is going to be 10 plus 5, which is equals to 15. So this is 17. So note this is very important. So if I now ask you now, since they are moving in the same direction, you remember that relative velocity is simply, so let's say relative velocity of A, it will simply be RA equals to, equals to velocity of A minus velocity of, that is, if I say find the relative velocity of A due to B, that is what B, the person inside, everything about, let's say this B car now, the observation of someone inside this B car looking at this is simply going to be VA minus VB. So that is what relative velocity means. Relative velocity simply means, if I say relative velocity, your relative velocity simply means what another person sees when they look at you moving. That's just what I'm trying to point out. So relative velocity is simply how another object or another body can relate the motion you cause, or motion that is caused by let's call it the standpoints. So it's more like saying observer and observed. So whatever it is, if I'm talking about relative velocity of A, it simply means that I'm observing A. So what the observed is getting. So if that be the case, I know you make sense from what I'm saying. So this is going to simply be now 17 to relative 17 minus 15. So the relative velocity of A will simply be equals to 2 mph. But if I now ask you, what will be the relative velocity of B? That is relative velocity of B. It will simply be 15 minus 17, which is equals to minus 2. And this thing makes sense. So anything relative velocity is always having the formula. That is, negative sign is always in between once it's in the same direction. So this thing will make sense, because if you check it, you see that if this person, let's say relative velocity of A is what we are talking about, due to B, it simply means that the person inside A, which is that is inside this car B, that is observing A, we notice that A is ahead, that this particular object is ahead of it, so it's increasing, it's plus. But when this person is observing this one, this person here will see that this is behind, so it's less. So it's more like saying the one ahead is observing what is below it, or what is behind, while the one behind is observing what is ahead, or what is increasing. So when I talk about relative velocity of A, it simply means that what will B see as A is moving, and if A is ahead, B will see that A is ahead, just from this illustration. And if I ask you relative velocity of B, it simply means what will A, an observer, see when B is moving. So now that I've known that, let's now say in the same dimension, but this time around they are moving in different directions. So let's say I have a car moving 2 meters per second. Let's say I call it A. Let's say I have another car and I call this, let's say they are moving in different directions. This is 3 meters per second. Let's say this is B. Now automatically, when it's relative velocity, you still remember that you're always checking relative velocity of A or relative velocity of B. So it's always between two things. It can be more, but it's always between two things. So and you're always going to be checking from this standpoint, So once and always remember that the key thing there is that if it's relative velocity of A, it will start from A minus that of B. And if it's that of relative velocity of B, it will be relative velocity of B, or you say velocity of B. Let's do this with velocity of. So velocity of B for relative velocity of B minus velocity of A. But notice something. Always pay attention to the direction. The one that is moving in the left axis, this is moving in left direction, and left direction means minus. So that means that B here is actually minus. So this is going to be minus. So this is going to be minus, or read. And for that reason, because this is moving in this way, it's going to be minus. So it simply means that when you are considering relative velocity, attention should also be paid to vector direction. Vector direction in terms of saying once something is going left hand side, notice that any value given there must go and have negative sign. So it's very important. So if I'm to check this will simply be the sentence as saying 2 minus 3, because this is not just 3. This arrow means that is a negative value. So, and if I'm doing this one will simply be now minus 3 minus 2. So if you check it, relative velocity of A will be simply 5, and relative velocity of B will be minus 5. So note that. So I had to do this. So I believe as we progress, we have more examples. Let's say I have a car now, and let's say I have a ball inside this car. Now let's say I have another car, and then this car is moving with 30 meter per second square. This is moving with 10 meter per second square. Sorry, per second. What are you doing per second? Let's say they are moving in different direction, and this one that is here is also moving in the same direction. Assuming it's moving maybe backwards. You see that if it's moving backwards, for it to be moving backward when this car is moving, it will be having that issue. In that case, it will not have negative sign, but provided that is here and is the same, this is going to be, let's say this particular one is moving with 2 meter per second. So this is going to be for the ball, since it's the ball, and they ask us now that, let's say the question says find the relative velocity of the ball. What it will simply be is the velocity of the ball and that of the car. So this will be simply 32 meter per second for here, adding it up. I know the ball here is 2, but if they ask relative velocity of this ball with respect to this, what the person inside here will be seeing is the velocity of this car and the ball. So relative velocity of the ball will be equals to 32 minus 10. And remember that this is moving in opposite direction, so it's already minus 2. So it's going to be minus 10. So this is going to be the same thing as saying 42 meter per second. So the person inside this place, this is B, will observe this ball and the movement of the car. So relative velocity of this ball is simply what the person inside this car B will observe looking at this particular car as he moves and the ball moving as well. So that is just it. So relative velocity, when you hear relative velocity of anything, it simply means the observed motion of that particular thing by an external or outside observer. So relative velocity of A simply means motion of A as observed by B, while relative velocity of B simply means motion of B as observed by A. Thank you. So we've done the case 2, but I don't think we've really cleared this case 1. So as we progress, I'll still make more videos on it. I believe it lingered so much because I took some time off. God willing, we'll do more this period.